This chip does not just compute, it thinks. Imagine a processor that mimics the human brain, learning, adapting, and evolving in real time. It sounds like science fiction, right? But it's not. This is neuromorphic computing, and it's about to change everything, so stay tuned. Welcome back to Zetona Zone. Today, we are diving into the chips that might power the next generation of AI, and maybe even the first spark of machine consciousness. So let's break it down. Traditional CPUs, they are like calculators, super fast at following instructions. GPUs, amazing for pattern processing, the heart of today's AI. But both are limited. They are built around linear logic. Input, compute, output. No real understanding. Neuromorphic chips are different. They are inspired by the brain's structure. Instead of logic gates and clock cycles, they use spikes, neurons, and synapses. They don't just execute instructions, they learn from them. Here's the kicker. They use what's called event-driven architecture. That means they only activate when there is input, just like your brain. So instead of running 24/7 like a fan that never shuts off, they're more like motion sensor lights, only on when needed. This makes them insanely energy efficient. We are talking about up to 1,000 times less power for the same task. That's not just cool, that's crucial in a world of mobile devices, drones, and robotics. If this already sounds crazy, buckle up, as we are going even deeper. Think of a drone that does not just follow a pre-programmed path, but actually learns its environment, avoid obstacles, adapts its behavior, all in real time with near zero latency. That's what neuromorphic chips are enabling right now in labs and research centers. Companies like Intel, IBM, and even smaller startups are racing to bring this to life. Intel's Loihi 2 chip already has over 1 million neurons on a single chip. These aren't just test chips. They are powering real-world experiments, from self-driving cars to swarm robotics to cognitive prosthetics. This is not some far-off future. This is now. And it could reshape how we build machines, software, even how we understand intelligence. Here's a question for you. Where do you think neuromorphic chips will make the biggest impact first? AI assistants, robots, or medical implants? Drop your predictions in the comments. Alright, let's zoom out. The microprocessor revolution changed the world. Then came the smartphone era. And now we are at the edge of a new revolution. Brain-inspired computing, neuromorphic chips bring us closer to AGI, artificial general intelligence, because unlike current AI models that requires massive data and power, these chips can learn from limited input, context, and experience, just like you did when you learned to walk. But it's not all plug and play. Here's a challenge. Neuromorphic chips require new programming models. You can't just install Windows and go. Developers need to think differently. Build spiking neural networks instead of traditional layers. Even the hardware ecosystem has to adapt. The learning curve is steep, but the potential upside unbelievable. Imagine a prosthetic arm that learns your muscle patterns in real time, or a smart camera that understands context, not just motion, or a battlefield drone that adapts tactics based on its environment. These aren't fantasy. They are early prototypes powered by neuromorphic architecture. Now let's get real. Will this replace all traditional chips overnight? Of course not. CPUs and GPUs still dominate general-purpose computing. But in the world of real-time AI, edge devices, and low-power intelligence, neuromorphic might be the only viable path forward. If you made it this far, you clearly someone who geeks on future tech. So hit that like button, subscribe, and share this video with your most AI-obsessed friend. Thanks for watching. This is Zetona. I will catch you in the next one. Peace out.